Hello ladies and gentlemen, in this video I am going to be reviewing the CER that was part of the signature lab for the flame test. So in lab you should have collected data that looks like this. In my pre-lab video I talked about how we got these formulas and also how we got these metal ions. Now you do not need to know how to do that for this particular unit, but you will be learning that later on in Unit 3. But what you did need to get was all of this data here. So that is from watching the video that I had on Canvas. And then after you recorded the color, you then had to look at the data table up here to record the wavelength. So for an example, if we look at potassium chloride, when we saw it in the flame, it turned violet. So then we look up here at our data table and we see that violet has a wavelength of 400 nanometers. Okay, so that makes sense because we've talked about how the colors of visible light are always in order of Roy G. Biv, R being red, V being violet. So we can see that as we move from left to right in our electromagnetic spectrum, our wavelength is going to be getting shorter or closer together, like that. So if we have a shorter wavelength, we're going to have a higher frequency and a higher energy. And so that's why violet here we can see has a shorter wavelength, and that is why it is further to the right and would have a higher frequency. But the point of the video for today is to go over the CER that you were to answer on your own. So this was the CER that you had to answer. It says, how can the characteristic colors of light emitted by different metal ions be used to identify them? Okay, so when you are doing a CER, first you need to write a claim. Now your claim should only be one sentence, and you're answering the question that was asked. So how you should write your claim is using evidence that you collected, using observations you collected, and using data that supports that idea. So in this particular lab, I would be looking for this answer or something very similar. So it says, the colors of light emitted by different metal ions can be used to identify them because, now this is what you need to have. Each metal ion produces a unique flame color and wavelength when heated. Now this information that I have here is what we collected in the lab. So that is going to be what supports my answer to this question. Okay, and that's what I'm going to be using in my evidence section. Okay, so now as I move forward, as I'm talking through my evidence, I want to make sure I'm discussing flame color and also wavelength. So when you are doing your evidence, I'm looking for 3 to 4 sentences using the data to support the claim. Your data always comes from your data table. I'm looking for numbers or any other information that was in your data table. So in this lab, the information I'd be looking for would be color and wavelength. Now we took a lot of data in this lab. You do not have to use all of your data. I would use at least 3 metals data in this lab to support your claim. So this is the evidence that I have written down. I'm going to start with a complete sentence. In the lab, different compounds produced unique flame test colors. So that's my start. I'm now going to list information from my data table. So I'm using sodium chloride, calcium chloride, and potassium chloride. You can choose 3 others if you like. I'm listing the color that I saw and the wavelength for each of those 3 that I'm picking. Okay, so right now I've already used 2 sentences, and I'm looking for at least 3 to 4. So after I list that information, I'm going to add another sentence that supports why I'm using this data. The data shows that each metal ion produced a different color and wavelength, making them identifiable. Okay, so this is a nice closing sentence to support the evidence that I used to support my claim. Okay, now the last part of your CER is you need to use reasoning. Now this is the section where students have the hardest time. Claim, that's easy. You're just answering the question with one complete sentence. Evidence, that's easy as well. You're just going right to your data table, what information supports your claim. When you're in the reasoning section, this is where you're using the science behind what you observed. A lot of times, the reasoning section will be supported by pre-lab questions. So if you look back to the pre-lab questions that I asked you, a lot of them had to do with what is happening in this picture. So this is exactly what I want you to be including in your reasoning section. So if you look at my answer to number 4, I'm explaining what is happening to the electrons in the metal ions when they're heated in a flame. I'm giving the 3 different steps that support these 2 pictures, with the last step being a photon is emitted and seen as light. This is my science explanation as to what is going on with the flame test. So this is what you should be including in your reasoning section. So for the reasoning section, this is what I have written out. When metal ions are heated, their electrons absorb energy, and they jump to higher energy levels in their excited state. They release light as they return to lower energy levels in their ground state. This right here is a sentence that has a lot of key vocabulary. We're talking about energy. We're talking about the movement of the electrons, what specific state they are in, and why we see the light. So this is a great introductory sentence. Okay, so now we still want to go on to explain why we see unique colors. So each element has unique energy levels and colors, which allows us to identify the metal ions. This is why sodium always produces a yellow-orange flame, and copper always produces a blue-green flame. Therefore, flame tests can be used to identify unknown metal ions based on the unique color of light they emit. This would be a perfect CER. If you had written just this first paragraph up here, that's still a very strong CER, but you probably wouldn't get a 3 out of 3 in the reasoning section. You may get a 2 out of 3, because I'd be looking for you to go the extra step in explaining why each of these elements had a unique flame color. All right, so ladies and gentlemen, I hope that you make any revisions on your practice CER so that you are ready to go for your real CER, which is on the day of your assessment.